In the last lecture, we saw the SSL or TLS security, how it works. In today's lecture, we will discuss about a topic called IP security. And before we get into the discussion, let's take a look at the agenda. What are the learning objectives of this lecture? So we'll begin with the background of why we need IP security and what are the use cases, deployment scenarios, what IP security actually offers you, and then how exactly it works and what we exactly mean by security association within the IP security. That is what we are going to learn in today's lecture. Uh, to set the context in spirit, what we discussed in the last two lectures. So if you look at the TCP IP stack, our application layer is at the top, and then the your transport layer is below that, and then the network layer, and then the link layer, and then the physical layer. So again, the same set of layers are there at the year end. So you have the application layer, then the transport layer, then the network layer, and then the link layer, and then the physical layer. So the first security method that we discussed, S-MIME, was operating at the application layer, and then we said that the SSL or the TLS security operates at the transport layer. So if you build any security method at the application layer, it can work with only one application. So if you want to if you want to build the security methods for another application, you need to re-engineer that customized version of the security that you need to develop. So we said that at a transport layer, the SSL and TLS you can use that for any application. So in that sense, it's application agnostic. But although it is in textbook or theory that it is actually application agnostic, in reality, it is tightly coupled with the application. So for example, TLS cannot be used for applications which don't operate over the TCP. So first is you establish a TCP connection, and then you go ahead into the TLS connection and negotiation, what are the security parameters, and then you finally exchange the application data. But there are, although TLS is can be used for different applications, but in practice only the HTTP, which is actually prominently used nowadays for some streaming, video streaming and other applications, it is used. But nevertheless, it's in practice it is limited to only the HTTP. So now the question is, can I build a method security mechanism which can be used by many applications? So in fact, it's actually transparent to the application. So something like this is happening beneath the application need not know. So that is where the IPSec come into picture. And what IPSec does is, as the name suggests, it operates at the IP layer or the network layer. So IPSec is a security method which provides the required confidentiality and other services at the network layer. So in fact, in true sense, it does not operate at the network layer. You can think of something like this. So if I start right from the application layer, and then the transport layer, and then the network or the IP layer, so you can think of it as IPSec sits somewhere between the in between the IP layer and the link layer. So this is where the addition comes into picture. So this is not a layer added to the TCP IP stack per se, but looking at the operations, what the IPSec does. So this is what you can think. So what exactly it implies is, it takes the IP packet or the IP datagram, which is the technical name for the unit at the network layer. So it takes a datagram, IP datagram, and does some additions or modification to that particular datagram, and then transmit over the network. That is where it's actually sitting in between the IP layer and the layer. So something, and so your original IP header is still there, IP packet or the datagram is there, and then there are some slight modifications that are done to the datagram packet depending upon what kind of service you want. You will see that what kind of services the IP security actually offers in a minute. So if you look at the features, so IPSec offers you the confidentiality of the data by encrypting the data at the network layer. So you take a IP packet and then you can encrypt it. That is possible with the IP security. So as I said, if you encrypt at the network layer, the application layer itself, the application itself is not in the picture. So something like this is happening beneath the application need not know. So that's why it's actually transparent to the application. Any application can actually use IPSec. And it also provides something called data origin authentication. So meaning that, so if a IP datagram is received at the some recipient, so the recipient can know that this packet is indeed come from the source which has actually sent it, from where it is at least claiming to be has come from the source. So the recipient can actually verify that. So that service the IPSec provides. In the process, it also provides the data integrity. So data integrity again is provided. You use some kind of the hashing algorithm or the MAC algorithm, and then you attach that MAC algorithm so the recipient can recalculate and compare the hash values and see whether something has changed in the transits. So these are the three fundamental services or the features that IP security provides you. One is the confidentiality of the data, and the second one is the data origin authentication. So who is the sender? The recipient can actually verify that, and in the process it also can verify the integrity of the data, meaning that the data itself has not changed in the transit. So along with this, it also provides an additional feature called replay protection. So replay protection is something like this. We did discuss this earlier, but just to recap, if the original sender is here and the recipient is here, an adversary sitting in the middle, if a packet is sent from the sender to receiver, let me call that as P1, and this packet is captured by the adversary, and this packet itself has reached the recipient, but an adversary at some point later cannot retransmit the same packet to the recipient. So retransmit in the sense the recipient taking that packet and processing, that cannot happen. So you can retransmit any packet in the internet just by sending that to the recipient address. The packet would go, but the recipient would not acknowledge that. It will not process that packet as this is indeed come from the source. So let's see how exactly this is provided, and this is an important feature of the IPSec. And we said that IPSec encrypts the data, and it also provides the integrity and the data origin authentication. So you need keys to secure this. If you want to encrypt this data, you need a key. If you want to use a MAC algorithm, then you need some kind of a secret key to be used, which only the sender and the recipient knows. So how do we actually distribute these keys? So how do we know ensure that the sender and the recipient know what keys are used in the communication, particularly for this communication. So the way it operates is, before you actually transmit the data from source to the recipient and the direction, the 2 point endpoints of the communication need to again negotiate and establish some kind of the parameters and then subsequently use. This is more or less similar to what we discuss in the TLS and SSL. So before you actually transmit the data, you actually establish this one. So the only difference is, in the TLS connection, it is per every application you need to establish one TLS session. But in the IPSec, you can establish once, and then irrespective of what application is actually transmitting the data, the same security association parameters can be actually used for the interaction. So these are the features. So again, to recap, it provides confidentiality, integrity, and the data origin authentication, and of the previous packet is actually not possible. So before we actually look into the technical details of how exactly the IPSec does what it does, so let's motivate ourselves by looking at some of the use case scenarios as we speak today, how exactly IPSec is actually used. So the most prominent use case of the IPSec is with the VPN, something called as the virtual private network. And maybe VPN is used for providing called a branch office connectivity. Meaning, think of this case. So you have a headquarter maybe at some place, let's call in Bangalore, and then there is a branch office at some other location. Maybe in Delhi there is a branch office of the same, some IT company. So the people sitting inside the branch office want to have a seamless connectivity to the main headquarter. So as if they are part of the headquarter, they are actually exchanging the data. Maybe let's say there is one application developed inside for that corporation, and that works inside only the intranet. So can we have the branch office, let's say this is the headquarter or office, and the branch office is somewhere maybe that is slightly small. This is a branch office, and I want to, there are some users inside this branch office, and then there are some users. Users mean these are computers or servers, whatever it is. So some, you can, for the sake of simplicity, you can assume some people are there, they are sitting with the computer. And what I want is, there is one internet application. So that application need be accessed by some people sitting inside this branch office also. How do we actually make sure that such an application, such a seamless integration can happen? So this is typically done with a VPN tunnel. You establish a tunnel from the headquarter to the branch office here, and then whatever the traffic which is meant to be going to the next can actually traverse over the public internet. This is the internet. Over that internet, the traffic which is meant for consumption to some users sitting in the branch office. So you take the transmission from here, and then provide some kind of security at the IP layer, and then transmit over the public internet or the public network, and then at this point of time it is taken out and then given to the intended recipient or the user. So that is the one use case. So in order to make this happen, you required IP security practice. So that is one use case. And the second most prominent use case is again going by the same, let's say this is the one corporate office. So let's take the same example. This is the headquarter, and then there might be a user sitting at home with his laptop or the computer, and he is doing something, and maybe he is working from home, and he wants to access some of the servers that are there inside this headquarter premises. So how do we actually provide secured connection to this end user, so that he can actually access, he can perform the duty as if he is sitting here inside the quarter and then accessing the data. So that is what required. So this, for this case also, where a remote user sitting inside his home is accessing a service or a server which is actually located inside your corporate premise. So this is another prominent use case of the IPSec. So again, you establish a VPN tunnel from your home to the your corporate office, and then you access as if you are part of the same network. You access, this is provided. So I said that the whatever security that we're talking about inside the IPSec happens at the network layer or the IP layer. Now the question is, where do this security? It is actually beneath the IP layer. You can think of this as a layer inserted below that layer. So where do I actually implement this feature? There are two ways of doing it. One is you can implement at the host level. That is the host level. So there is a user here and there is another user here, and he is sitting with his laptop or the computer, and the other person is also having a laptop or the computer. So these two users, end systems themselves, implement the IP security feature, meaning I am going to insert or add the code or the feature corresponding to IPSec to these two end hosts, these two computers, meaning the TCP IP stack of these two computers, and they themselves establish a tunnel between them, and then then they talk to each other. So this is one scenario. So if this is what is required, then you can think of the implication. So you need to tweak with the TCP IP stack of the every computer, every user who is there. So how many computers are there? So all of them, whichever is required to use IPSec, in all of them you need to do this changes. So that is one case, but this is rarely used. So unless the end user, in the case of where the remote user is sitting at home and then trying to access, unless that happens, this is not used. But the other prominent use case is you does not implement in the end host, but you implement inside something called as the middle box. The scenario goes something like this. You have two networks. So maybe the same, this is the branch 1 and branch 2 of the same network. And then there are, as I said, there are a bunch of users inside this network, and similarly there are a bunch of users inside this network. And at the perimeter of the these two networks, there are devices. So these are called perimeter devices. So this could be a router or a firewall, typically, or might be, you can also you can think of this as a switch. Switch is a generic name, not necessarily the layer 2 switch that we do. So it can appear in any of its format. So you implement the IPSec feature at these middle boxes. So meaning, so if a user from here sends a packet to this perimeter security device, and it is for consumption of this user located in the another branch office. So without this user knowing in the branch 1, the middle box here does or adds the required security and transfer that packet to this place. So let's call that packet as P1, and then the P1, the peer entity, peer middle box sitting at this boundary is actually taking out that packet and then transferring it to the intended user. So this is where another thing. So now the things becomes much more simpler. So I even don't have to know what exactly is happening and how what kind of encryption algorithm is used, what kind of key is being used. So everything is transparently managed by these middle boxes on behalf of the end users. So that is one case, and in fact this is actually particularly to provide connectivity between the branch offices of the corporate. This is typically used. So seamless, you don't have to negotiate multiple keys for every pair of user and all those things. So in one place you concentrate everything, and then the encryption decryption happens seamlessly without the end user knowing or even experiencing anything. Something like this actually happening. So this is another place where you can actually, one is at the end host level and another one is at the middle box level where you implement the IPSec feature. So two things. Now the IPSec, although say technically it can provide the confidentiality of the data and integrity and data origin authentication, providing confidentiality is an optional quality. So meaning if you want it, you can use the confidentiality service, but if you don't want the confidentiality, you can actually live with only the authentication. Towards the what kind of authentication? Only the data origin authentication. I just want to know that the packet that I received has come from so and so source, nothing more than that. So these two methods of security, although only authentication is actually not in true sense the security, but it's actually under these two, whether you want the only the authentication or the confidentiality as well, is divided or provided with two different methods within the IPSec specification. The first one is called the authentication header. So authentication header is actually providing only that authentication. So and so packet has come from so and so source, nothing more than that. And the second method, if you want the confidentiality along with the authentication, so you use a method called as encapsulating security payload. So in short form, these two are denoted with the letter AH and ESP. ESP stands for encapsulating security method. So if you use the second method, then you get both confidentiality and the integrity and also the authentication of the packet. So since the ESP actually provides the authentication as well along with the confidentiality, so in some sense the only the authentication feature, this is actually rarely used in practice. In that case it's actually deprecated. So although technically it is possible to do it, but in practice it's actually not used. It is the ESP which is by far the more widely used in IP security method. So that is on it is. So if you want the confidentiality, use ESP. If you want only authentication, then probably you can use the authentication header. Both, whether you use the only authentication method or the authentication header, or you go with the ESP, both of these methods can operate in two different modes. One is called as the transport mode and the second one is called as the tunnel mode. So the fundamental difference between these two are the following. In the transport mode, what the IPSec does is it takes the IP packet or the IP datagram and then without modifying the original IP header, it inserts away. So this is my original IP packet and it has got a header. This is the IP header, and what it does is, in the transport mode, the original IP header is kept as it is, and something in the middle, a new header is added here. This let's call for the being new header, and then whatever is there from here to here, that is kept at is. This is typically maybe your data, or you can call it as payload, and the same thing, whatever is here between here and here, the payload is as it is. So this is the transport mode operation. So you don't modify in the sense you retain the original, because there are a couple of minor changes inside that IP header. We'll take a look at that. So you don't tamper with, manipulate the original IP packet. So in that case, who is the sender, who is the recipient, that will be known. So for example, what I'm trying to say is, if the sender is here and the recipient is here, and I have two routers in between, if I send a packet, let's say P1 from S to the recipient R, since I am not modifying the original IP header, so let's say the sender's IP address is 10.10.10.10, and the recipient IP address is 20.20.20.20. So who is the sender, who is the recipient, those fields are not modified inside this header. So those are the source and destination IP addresses. So as when the packet P1 is received by this router, let's call this as R1, R2, R1 can make out who is the sender and who is the recipient, where the packet came from where, and where exactly it is going. So that is possible with the in this case, in the transport mode. On the other hand, if you use the tunnel mode, then what actually happens is, the entire IP packet, the original IP packet is there in IP header, and then the payload is taken, and then this is actually encapsulated, meaning a new IP header is attached to this new IP header, and the old IP header, whatever is here, that will also be there. And then payload. So basically, what you do, you take the original IP packet and then cover it over, and then send it to the entity. By attaching a new IP header. It's not only the new IP header, there is another additional field that comes with this one. So for the time being, let's call it as there is a old IP, existing IP header, whatever came from the came in the original IP packet, that is there, and then a new outer IP header is created. So by doing this, the advantage that you get is, if you have this kind of the scenario, let's say the packet came from the IP address 1.1.1, the original IP packet is carrying the source IP address of this one, but this middle box can also have a new its own IP address. So in the outer IP packet, the new IP header that you are adding, you can actually put, or this device middle box can put its own IP address, but inside whatever is there, so for there the original IP address can still be there. Thereby, if I send such a packet, these middle boxes R1 can know that the packet came from 2.2.2 so and so network, but not who is the user who actually sent that packet to the other end, or who is the exact recipient at the other end. That will not be known. You can actually hide the identity of the two end points by doing this one. So that is possible. So if you use the tunnel mode, this is exactly what happens. So we'll take a look at what are the specific changes that happen inside the IP packet, whether you use the transport mode or tunnel mode, and then whether you have you use only the authentication header or the encapsulation security packet. So depending upon these two, there are four combinations. One is you go with the authentication header, then either you use the transport mode or the tunnel mode. You use the ESP, and then you have either go with the transport mode or the tunnel mode. In order to understand that, let's take a quick look or recap of the how an IPv version 4 header format look like. How it look like. So it has got version number, header length, type of service, total length, identification field, and some flags and fragment offset, time to leave, or we call it TTL. And then the important field for us is this field called as the protocol field. So what protocol field tells you is it identifies at the upper layer which entity is actually carried. So whether this is an UDP datagram or this is a TCP's the unit. So either of these two. So at the upper layer, which is that application, which is that transport layer service, which protocol, which is actually giving the data to the IP or the network layer. That is what is identified. So this is typically done by putting a number. So if it is a TCP, then the number, a value 6 is returned in this field. So if it is UDP, then it's actually the number 17 is written. So in the sense, so if you look at the IP packet, this is what happened. So here is the IP header, and then you have got the TCP header, and then the application data or the payload. So within this IP header, this field, protocol field, is actually carrying this number, meaning that it is actually identifying what is the next header type that is actually beneath this. At the outer upperly, you have the IP covering, and then beneath that you have the TCP or the UDP header, and then the data. So it is actually, in some sense, it's actually pointing to the next header. So outside IP layer, and beneath that what exactly is there. So that is identified by this number. So I will not go into the details of the other fields. So I think it's self-explanatory. All of us have seen this IP packet header many times. So without going, assuming that know the meaning of the other fields. So let's exactly see how exactly these two combinations actually change the IP packet.